The development of science and technology of advanced materials using nanoscale units can be conducted by a novel concept involving combination of nanotechnology methodology with various research disciplines, especially supramolecular chemistry. The novel concept is called nanoarchitectonics, where self-assembly processes are crucial in many cases involving a wide range of component materials. The examples in this review cover variously structured objects including molecular machines, molecular receptors, molecular pliers, molecular rotors, nanoparticles, nanosheets, nanotubes, nanoflakes, nanodiscs, nanoings, block copolymers, supramolecular polymers, liquid crystals, Langmuir monolayers, Langmuir blodgett films, self-assembled monolayers, thin films, layer-by-layer structures, breath figure motif structures, two-dimensional molecular patterns, fullerene crystals, metal-organic frameworks, coordination polymers, orthogonal dielectrics, light harvesting, photocatalysts, field effect transistors, logic gates, organic semiconductors, thin film-based devices, drug delivery, cell culture, supramolecular differentiation, molecular tuning, and hand-operated nanotechnology.
This article is titled Self-Assembly as a Key Player for Materials Nanoarchitectonics and was authored by Katsuhiko Ariga, Michihiro Nishikawa, Taizo Mori, Takeya, Kumar Shrestha, and Jonathan Hill.
We are article.tv. Article links can be found in the video description.